So here we have solid ink technology from Xerox. It's a technology that's exclusive to Xerox. It's available in the market today. Basically, the number one feature or benefit to solid ink is that it's cartridge-free. So basically, you have this solid ink, and it goes into a printer, and it almost entirely melts and applies to the paper. And what it has is it produces 90% less waste when you compare it to laser printers or your traditional laser printers today because of that cartridge-free.
I'm assuming the colors that you see here are the corresponding colors of the ink once it melts?
It's a CMYK process, so there's four colors, and they drop in into the top of the product, and again, they can melt into a liquid form and get applied to the paper at that point.
Thanks. Cool.
Okay, so that's solid ink.
Great.
This is our spiral water filtration technology. This is actually a project at our Palo Alto Research Center, which is a Xerox company. And this is really what it's doing is it's trying to, if you think about traditional means of filtering water today, it requires abundant amounts of space and costs. And this is really a way to really streamline those costs, minimize those costs, and more importantly, reduce the amount of space required to filter water. So what you have here is a prototype to show, and the water circulates through this, and all of the sediments filter out to the outside part of the spiral and then fall out of the process. So what you have here, and currently where we're at, we've got a 90% of water, and there's a little video coverage here to show some of the technology back at Park. And it's got huge implications for developing countries today where some of these resources are quite limited.
Yeah. So is it low cost too, or?
Costs, we're still kind of in the project stage.
Yeah.
Yep, but
it's expected to be.
Great. Cool.
Yep.
Especially considering other methods.
This is a very exciting project. This is today we are actually showing this or launching this here at NextFest for the first time to the general public. This is another project that's currently happening at our Palo Alto Research Center called Erasable paper. We've had some research that shows in your typical business day, about 40% of documents end up in the bin. This technology is for that 40%. So what we have here is a mock-up to show you over the course of 24 hours how the paper would, say you were to print it at 9 a.m., the following morning it would then be erased and blank again and be able for reuse.
So this is for stuff that you know that you're not going to want in 24 hours or whatever.
Yeah,
Great.
you think about all those things that you just need really quickly. Even in leaving the meeting room, people are dropping them in the bin.
Yeah.
So it's for those. It's not for the contracts and things that you want to keep on file for a long period of time, but it is for that 40% of documents that end up in the bin.
It's the paper itself that's doing the erasing?
The technology is actually in the paper. And it works through an LED kind of process onto the paper.
And is this going through a regular printer, or?
It's still in development a little bit. They're working through that, but it would go through a printing device. How it works with today's technology, that's what they're still kind of working through.
Fair enough.
You can see a demo of it too.
Yep, there's another live demo.
Great.
Over here in this little pod, we have our security printing display. We've got 3 technologies, and we've mocked up kind of a sports ticket to illustrate the different technologies. On this particular one, it's actually gloss mark. So as this thing rotates into the light a little bit, you'll notice in the background, it's almost like a hologram. And so for a sporting event or whatever it is, you can put your name on it, just so you can get that much more protection against fraudulent activity. So all of these have great applications to like passports and birth certificates and things like that. That's one of them. That's called gloss mark. Over here, we have what's called fluorescent mark. And at the very top, behind this kind of, as I shut the light off, you'll see some numbers in there now, but when you shut the light off, it's not visible. So again, only under a UV lamp will you see all of this information in the ticket. That's one more, and then the final one, this is actually called microtext. And when you're actually holding the ticket, you can't see with the naked eye some text that is embedded in the ticket. So what we've done here is really blown it up so that you can see in the ticket that we've got some information. Again, this would be customizable. We've got the seat information here, but it could be your name, it could be whatever information, but it's an extremely small font size that, again, hinders the ability for things to be copied
Counterfeited,
or
Great.
misused. Okay?
Thanks so much.